Okay, now we're going to calculate the covariance and the correlation coefficient for the bond and stock fund. So we write covariance like this. So covariance, return on stock, return on bond. So this is covariance is similar to variance, but we're considering both portfolios. So take our probability, 0.05. We multiply that by the deviation for the stock fund, so minus 37 minus 10 multiplied by the bond fund. So we've got minus 9 minus 5 plus 0.25. So we did severe recession, we go on to mild recession. We've got minus 21 minus 10 multiplied by 15 minus 5 plus 0.4 multiplied by the 14% minus the 10 for the stock fund and normal growth. Then we've got 8% for the bond fund minus 5 plus 0.3 multiplied by the 30% minus 10. And then we give a loss of 5% for the bond fund minus 5. So all those together was negative 74.8. So now for the correlation coefficient, we have to so correlation coefficient is signified by rho. It's the Greek letter. So, and it's covariance, RS, RB, covariance, so return on stock and bonds. So the 74.8 divided by the standard deviation for stocks multiplied by the standard deviation for bonds. So we got minus 74.8 divided by our 18.63 multiplied by 8.27. And it comes out with negative 0.49. So what this tells us is stocks and bonds are negatively correlated, which is important because it really increases, having a negative correlation really increases the benefits of diversification. So if you have assets that move in opposite directions during different economic scenarios, that protects you, provides you with diversification benefits. So one other thing we can do, now that we have the correlation coefficient, we can use the formula and on slide 12 from the lecture to calculate the portfolio variance. So that is so sigma squared P is going to be equal to the weight in bonds, 0.6, multiplied by the standard deviation for bonds, 8.27. We square that, plus 0.4 multiplied by 18.63 squared, plus 2 times the weight in bonds multiplied by the standard deviation for bonds, multiplied by the weight in stocks, 0.4, multiplied by the standard deviation, and then we multiply all that by the correlation coefficient minus 0.49, and we should get 44.26, just like we did before. You might have a little bit of rounding difference, but it should be pretty close. So if you start to understand these relationships, it makes your life easier with regard to these calculations. For example, you can also use the covariance here, because the covariance is equal to the standard deviation for bonds multiplied by the standard deviation for stocks multiplied by the correlation coefficient. So you can simplify these calculations and make them look a little less ugly.